Is all fine?
Yes, yes, sir.
So are you improvising yourself to get more and more understanding, and when you see something you can see through that quantity or the information or the data? You are doing that, right?
Yes, sir. Right.
Yeah, develop the
Whenever
confidence and the
I'm trying to.
courage in dealing with anything. Okay, it's not that something is difficult for me, this thing is comparatively more easier for me, nothing like that. Okay,
Okay.
it is about the effort, like what you want to know. If you put the effort and try to do, I mean, the learning in a better understanding way, you will get it. Okay. Okay,
Yes.
last
Okay.
week we were looking into a trigonometric problem using the addition and subtraction of angles. Did you complete the problem?
No, actually I didn't.
Okay, you did not do the problem again, right?
No, no.
Okay, can we look into that?
Yes, yes.
Okay, so do you have the problem in the WhatsApp? I think I sent the image or
Yes,
something.
uncle, I have.
Okay. Okay, can you tell the problem?
Yes.
Are you using this writing pad to make yourself comfortable in writing on that, or you're not at all using it?
Actually, I'm not using it now since because of school and it's all normal, right? So I'm not using it.
Okay. Okay. So because I thought that I will ask you to write and solve the problem by yourself, but okay. Tell me what is the problem statement.
Yes, sir. Yeah. So 6.5
Okay. 6.5
minus 5 cos x
minus 5 times cos x
minus 12 sin x
minus 12 sin x
is equal to 0.
equals 0. And then the range for the x is
0 less than or equal to x and less than or equal to 2 pi.
2 pi. Because the range is important, because you see why I asked that question. As soon as I see this particular problem, it is not a simple algebraic equation. Do you see that? It
Yes.
involves trigonometric functions. So as soon as we see a equation and involving variable, how many variables are here?
1.
One variable in the name of x. And
X,
how
yes.
many equations are there? Only one equation, right?
1 each. Yes.
So the variable is completely solvable. That is the understanding we should have first. Okay.
Yes.
And the next question comes, okay, when we solve this variable x which satisfies this given equation, how many solutions this x can take? That should be the next question immediately.
Okay.
Okay, if it is a linear equation, that will be x raised to the power of 1. So the answer will be only one answer, one solution for the x. If it is a quadratic
2.
function, then 2. Like that, we know in polynomial terms, we know that. So now look at this. The x is appearing in two places. One place it is acted by the trigonometric function cos, and the other one is trigonometric function sine.
Yes.
So do we know about the cos function and the sine function? How it will look like with respect to, let's say we draw the, I will give you an example. Let's say we draw the x value, and if you draw the cos x, how it will look? You know that.
Shall you
So it will be an
pause it?
oscillating function like that, right?
Yeah. Yes. 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 Yes.
Okay, do you know why it looks like that?
Uh,
Yeah, so this will be, for example, 0 angle, and this will be our pi by 2, and this will be our pi, and this will be our, sorry, and this will be our 3 pi by 2, and this will be our 2 pi, right? So this will be cyclically repeated. So this will complete, so this particular thing will be one cycle.
okay.
and it will keep repeating, so it will repeat it. And it is not only for the positive, so on the negative side also it will be keep repeating. Okay.
Okay.
So this is actually called a periodic function. Periodic function. The understanding is actually, let's take a length 1 for example, and if you allow this one to rotate, it will complete one period. You get that?
Yeah.
So it will complete in 2 pi angle. So it will start from 0 angle, complete in 2 pi, and it will keep repeating doing the same job, right?
Yes. Yes.
That is why periodic function means it is repeatedly doing the same job again and again in a range of 0 less than or equal to x less than or equal to 2 pi. So same thing is going to repeat it again and again and again. So in doing so, let's say you are in a particular angle. Let's say you are in a particular value of the x. Okay.
Okay.
So still the length is 1, but the angle made is x. Here the angle is 0. Now it made a x angle. Then this can be resolved into the vertical component and horizontal component. Do you get that?
Yes.
So this vertical component will be our sin x, and the horizontal component will be our cos x.
Yes.
Okay, so if you see the cos x value, so this will start at 0 with a value 1, and it will reduce and it will go to 0 when it goes to the pi by 2, right?
Yes.
You see the formation of the, because here there is no triangle at all, right angle triangle, and then slowly the right angle triangle is forming. Do you get that?
Yes.
And the cosine value is reducing and it will go to 0 when it is pi by 2. That is what we plotted here from 1 to, so from 1 to 0. Are you with me?
Yes.
Yeah, so the sine will, at the same time, the sine will look like from 0, it will start going like this. So this is 0 and this is pi by 2, it will go to the maximum value, and this pi, it will go to the 0 again, and 3 pi by 2, it will go to the negative maximum, and again at 2 pi, it will come back to 0.
0. Yes.
So that is why it is looking like a waves there. That is why we call them as a waves. Okay. So do you see that oscillation? So the cos x is starting from this point. It will go to 0 and go to the other side and keep coming back. So it will be repeatedly oscillating. Do you get that?
Yes.
So if you look from, so if we keep our eye here, okay, and look it here, this eye will look at like this. Do you see that? This point is this point, and when it comes back to 0, this is the part we see. Go to the negative, this part, and go back to 0, this part, and then come back to 1, this part. Yes. But if you look from the, when you look it from here, when you look it from here, this side, the sine will start from 0, go to maximum, come back to 0, go to negative maximum, come back to 0.
Then go down.
That is what this is. Right?
Yes.
So if you see, this is our x actually. So when you have a x, so when this is the sine of x. So it is not having, let's say if this sine x is, they are giving a value, let's say the sine x is off, right? This is an equation.
Yes.
You understand this? So we have to go to the, this is the sine x, y axis value, go to the off, this is our off, that is what this says, then draw a horizontal line, then it will meet this, the sine function at infinite points. Do you get that?
Yes.
The one at, first one will be our pi by 6.
Yes.
Pi by 6 is one solution, and this point will be just 30 degree before the pi, that will be 150 degree. Do you get that?
Okay.
Okay, and again here that will be after the 2 pi extra 1, so this will be 2 pi add with our pi by 6.
Okay. Yeah.
So the solution, so the sin x equal to half will have solution like, I mean, negative solution angle is also there, but we go only positive. The first one will be pi by 6. Second one will be pi minus pi by 6. Right? Next one will
Yes.
be 2 pi plus
2 pi plus 5.
pi by 6. That is 320 plus 30, that will be 350. Okay. With 360 plus 30, that will be 390, and then it will go again, that will be 3 pi minus pi by 6. So there are infinite answers for this particular simple equation sin x equal to half, because it is a periodic function. Repeatedly it may come to the half value many times, infinite times. Okay,
Yes.
are you okay? Do you get the understanding of it?
Yes. Yes.
Now also we have a given problem is 6.5 minus 5 cos x minus 12 sin x equal to 0. Even though it is only a single variable x, single equation is completely solvable, but we are looking for infinite answers for x which can satisfy this equation, right?
Yes.
That is why they give a range, like, okay, you may have infinite answers, but give me answers only for the range, for only one cycle from 0 to 2 pi.
Yes.
Okay, so okay, that is actually, if this function can be plotted, it may look like a periodic function, and if you can mix the x is appearing in two places. First job is to make it appear at only one place, then only we can solve the problem.
Yes.
Okay, to do that, we did, what is the first step we will do?
6.5 is can be written as 13 by 2.
Okay, that also we can do, but before that, I mean, I will keep all the unknown quantity terms on the left side and known quantity on the other side. So it will be 5 cos x plus 12 sin x will be equal to 6.5, first step. Okay. Now, as you said, 6.5 can be written as a 13 by 2. That is also okay. 5 cos x plus, my writing is okay, right, for you?
Yes. Yes.
Yeah, sin x equals 13 over 2. Okay.
Yes.
So now the cos x is containing a x, sin x containing a x, but the cos x has a coefficient 5 and a sin x has a coefficient as a 12. So here, when you have something like a cos x add with a sin x, and we have numbers 5 multiplied with the cos x and 12 multiplied by a sin x, remember that, I mean, the compound or addition or subtraction of the angles, remember this could be easily take it as a remember the two identities, right? I will write it here. Okay, so the cos a minus b can be expressed as a cos a cos b plus sin a sin b, right?
Yes.
Sin b, and similarly sin of a plus b. You know why I take the cos of a minus b? Because there is a addition going on here. So similarly sin of a plus b is actually sin a
cos b,
yeah,
plus cos a.
Yeah, plus cos a sin b. I wrote both these identities because we have something multiplied with cos x and another thing multiplied with the sin x. So both these expressed way can bring the a and b together as an addition or subtraction inside one function. That will help us a lot, right? But to do that, we need to express this 5 as a in terms of something like for example, if this can be expressed as a cos some another quantity y, and this is a sin y, then this whole thing will look like cos y cos x, sin y sin x, then that will fit into this category. Do you get that?
Yes.
But the 5 is too much. I mean, the cos or a sine function maximum is positive 1 or negative 1. Okay.
Yes.
So we cannot make the 5 to be our. So we need to think about it. What we can do so that this could be made less than. So we need to think about. Let's say
Divided by.
Yeah, but we need to. One is a 5 and another is a 12. So think about these two things are actually forming a right angle triangle.
Yes.
Okay. If this is our y, and if this is our 5 and the opposite side is a 12, I choose the 5 because the cosine is actually related to the 5. That's why adjacent side of the y I am taking it as a 5. Okay. So this will become square root of 5 squared plus 12 squared, right? So the answer is
13.
13. Okay, so that's good. So we have a right angle triangle in the new angle y. So this is actually going to tell us the cos of y is going to be adjacent side of the y is a 5 divided by 13, and our sine of y is going to be the opposite side by the hypotenuse 13. Okay.
Yes.
So this hypotenuse value. So the hypotenuse value as a 13 is actually giving us the idea what number we can divide this equation from. So divide this by 13. So that will become 5 over 13 cos x plus 12 over 13 sin x should be equal to off. Not 1, off.
1 by 2.
Yeah, 1 by 2. Okay. So this one we just made it as a cos y cos x plus sin y sin x, right?
Yes.
Equals off. So now with the identity we can write this whole thing as a cos y minus x, which is actually equal to off, right?
Yes.
So now we made the appearance of the unknown quantity x in two places to appear as only one place. It's a great achievement. So now take the cos inverse on both the side. So it will give you y minus x is actually cos inverse of that is actually root 3, I mean 60 degree, right? That is pi over 3.
5.
Okay, so now we need to think about it. Pi over 3 is, first of all, we need to write it in terms of radians. Yeah.
Uncle, last time whatever we did, last time we got the answer as
No, you are yeah, that is why I did purposely like that. Last time we made the both the thing combined together to become a sign identity, not a cos identity.
Now it okay. Yes. Okay.
So you see, is not limited by the. It is about the given problem. What we proceed with will leave out with. So our final answer will be correct always.
Okay.
But I purposely, instead of rather than making the whole thing as a sine of a plus b, I made it as a cos of a minus b.
Okay.
In the previous time, last time, we would have got
we took sine of a plus
alpha as the angle. We got x plus alpha as a pi by 6.
Yes.
But now it is y minus x. Do you get that?
Yes.
As long as our understanding is correct, our procedure is correct mathematically, we will get the right answer. Okay.
Okay.
But now we have a situation. So we are saying that the cos inverse of off. So we need to go to this thing and go to the off. Do you get that? Do you see where I put the point?
Yes.
The cost graph. So if you
Yes.
go, then within the, so we are given a limit of the x value is within the range of 0 to 2 pi. So we need to go and meet the in two different places. So one will be our pi by 3, and we are having another value here. Do you see that?
Yes.
So that will be just after 3 by pi by 2. So that will be 3 pi by 2 plus pi by 3, isn't it?
Yes.
No. No. It could be. So this is actually our 2 pi, right?
Yeah.
So an angle before. So it is actually, this is wrong. Okay, I will use a eraser. You have to be careful here. Okay. Okay, I will do it again. So what we are looking at, let's draw the cycle. Okay. So when I am drawing a sign, I want the cos. So I draw a cos function for 2 pi, right?
Yes.
So this is actually our pi by 2, and this is our pi. This is our 3 pi by 2, and this is our 2 pi, right?
Yes.
So this is our 1. If you go to the of the value, we have two. First one is pi by 3. Second one is a pi by 3 before 2 pi. Do you get that? 2 pi
Okay. Yeah.
negative pi by 3. Okay, otherwise we can say it is a pi by 3 and minus pi by 3 will be both, our cos inverse of will be a positive 60 degree and negative 60 degree. Do you get that?
Yes.
So that's it. So the solution is x is actually equal to, so we have the y minus x is two angles within the range of 0 to 2 pi. So
Yes.
now we need to write the negative of that and then subtract with y, right?
Yes.
So if you multiply, yeah, and then add with the y. So if I am not wrong, it will be y minus pi by 3 and a y minus in the bracket 2 pi minus pi by 3. Okay.
Yes.
Okay. Can you first of all we need to solve for the y. So the y could be easily, so the in this thing we can solve that y is actually sine inverse of 12 by 13, right?
Yes.
Do you have a calculator?
Yes. Sir.
Yeah. Can you go to the radian mode and tell me, divide the 12 by 13 and take the sine inverse, get the y value.
Radian mode.
Yeah, because we are working everything in the radian mode.
Yeah. Yes. Yes, sir.
Yeah. Two decimal places is fine. Tell me, round it to two decimal places.
I have to calculate 2 pi minus.
No. Give me the y value. I am saying you are jumping ahead, and that is not the. I mean, our goal is not only solving the problem, understanding and doing it in the proper way. Do you get that?
Yeah.
1.176. You get this?
Okay.
Radian. Did you get this?
Yes, uncle. I got one.
Can you check that for the cosine also? Cancel everything in the calculator. 5 divided by 13. Take the cos inverse. Tell me in radians.
Okay.
That can also be 176. We need to make sure that we are correct in all possible ways. Okay.
Yeah, 1.17.
Okay, now tell me, now we got the y value. Can you take the 1.176, subtract 5 over 3?
Oh.
Use the pi value in the calculator.
0.12.
0.12. And only 1 2, no other next number?
1288.
So 0.129.
Yes.
Yeah, but if you say only 0.12, it should be 0.13, right? If you round it off.
Okay. Yeah.
So it is a 0.1299.
Because after it's 880, so.
Yeah, but you know how to round numbers, right?
Yes, sir.
Can you round it and tell me what is the value?
Uh, 0.129.
Oh, yeah, 0.129, right?
Yes.
Okay, I go with that. And how about the second answer?
Now.
You need to first subtract 2 pi minus pi over 3. Then keep that value. Then 1.176 should be subtracted from that.
Right? Uh, 2 pi minus pi by 3 is 5.23.
Yeah. Okay. Huh? There we are. No, what is this thing going on? Okay, that is 360 minus 60 is 300, right?
Yes.
Okay, 300 is off. That is correct. So 2 multiplied by pi minus pi divided by 3. Yeah, this number is okay, but if you subtract we are not getting a value within the. You see the trouble what we have now here. So
Yeah.
we are not going to that angle. So we need to think about, because we need to find an answer, because if you put the y value as a 1.176 minus 5.236, that will go to the negative value.
Yeah.
So the negative value will be in the, that is not within the range of 0 to 2 pi.
Yes.
You get that? So let me take it. So minus 1.176 17176. That will be negative 4.05. Yeah, of course, that is an answer that will satisfy, but that is not going to help us because we have to find the.
Yeah.
So can we find that within that that limit? So that is actually giving us trouble. Why? Y minus pi by 3 is fine. Yeah, and this thing has to be okay. I will erase all of the. You are okay with that, right? All these things.
Yes.
Okay, so I will go to that only one point. Clear all drawings. So I will go to that problem as a y cos y minus x is actually equal to half, right?
Yes.
So we can say that okay, so this is can also be half, and also the cos negative of y minus x will also be half. Do you see that?
Yes.
Because in the okay, this can be understood in two ways. Okay, so this is the all silver tea cups. So the cosine, so if you take an angle, this is theta, clockwise anti-clockwise direction, this could be also minus theta. So the cos of theta is also the positive one, that is cos theta, and the cos of minus theta is also cos theta. So that is what I have written here. You're okay with that, right?
Yes.
Okay. So now we are just saying the okay. So that means y minus x is actually cos inverse of half. Similarly, minus of y minus x is also cos inverse of half. Okay. Are you okay?
Yeah.
So this will be, take the solution as a pi over 3, and this solution also pi over 3. So this leads to the x is y minus pi over 3, and this leads to x equals y plus pi over 3. Okay. So 1.176 or something. So x will be something like, what is the first answer? So I computed like 0.126 to 0.22.
Okay.
0.126 and 2.22.
Yes.
Okay, in radians.
Yeah. Okay.
Are you okay with that?
Yes, sir.
Okay, so the whole idea is we need to use the information available, the given problem or whatever the data and everything, and try to disintegrate or disseminate them into a way that we can use the available thing one by one with our understanding of if it is a cost function or if it is a polynomial or something like that. Can we use our understanding slowly, step by step, one by one, to proceed with a way to solve the problem? Okay. Okay, that holds good for any problem. So hope this problem actually help you to do that. Because straight away, if you are given with 6.5 minus 5 cos x minus 12 sin x equals 0, and within the range of x going to pi, it's not an easy problem to solve straight away by the look of it.
Yes.
But I helped you to how to go about it and understand that okay, one variable, one equation solvable, but it is appearing in two different places, one with the cosine, one with the sine, and how to connect them, how to bring them together as a one single x in only one position. We made use of the coefficient available in front of the cos x and the sin x to bring it together using the cos identity, and we did that. Okay.
Yes.
Okay, so like any problem we should always do like that. Okay.
Yes.
So do you want to proceed with more problem in trigonometry, or you want to, you are okay with looking into other problems, and you want me to go to next topic?
Okay, can we go to the next topic?
Okay, so you are okay with so far
Yes.
whatever we discussed, right?
Yes, sir.
Okay, so basically we are going to see that, okay, I mean most of the time there could be simply like a function which is dependent on another variable, a variable dependent on another one, so we call this as a independent variable, right?
Yes.
This one is dependent on that, dependent on the independent variable x. Okay,
Yes.
so this could be any simple example in our life could be like that. It could be x, I mean the independent variable, most of the time the time itself could be that, sorry,
Yeah.
the time is a independent variable because it is not dependent on anything, it can change on its own, right? Okay, so when we have a time as the independent variable, then the y can be dependent on that. It could be anything. For example, it could be a fruit basket having the number of apples. Okay,
Yes.
so in the morning it could be having some number like 5 apples, and then afternoon somebody took 2 apples for eating or something, then it would change to 3, and evening you go to the market and buy more apples, you add a dozen apple with the 3, then it will become 15 apples. So you see the number of apples will be dependent on the time.
Yeah, it's very, yeah.
So when we have data like that with the different, so we are talking about a independent variable value and a dependent variable, so we can combine two data. So x itself will be some set of data, so it can have like for example 1 2 3 like that, or it could be like from whatever the value -3 -2 -1 0 1 2 3 like this. Okay, or it could be like even like 0.1 or 0.2 or 0.3, depending on how we measure the time or representing that quantity. The values can have step size like this. Okay,
Yes.
and depending on that we may have the y measurement also. So most of the time by measuring some quantity with respect to some independent variable, we may have data and we may need to represent them. So that is why we write it as a function. Y is dependent on the x, and can we define that using a particular mathematical function. For example, if you write it as if you draw it as a graph between the x and y, if you have the data and plot them, it may look like this. Okay, then in that case we write it as this is a straight line, so it will be a mx plus c, right?
Yes.
Okay, y equal to, you are looking at here and listening to me, right?
Yes. Yes.
Okay, so when we write like this is a linear function, why it is a linear function, in the y equals mx plus c, there are two variables and x is one variable which is the independent variable, and y is the dependent variable, right? Hello?
Yes, uncle. Can you hear me?
And we have two parameters.
M and C.
Yeah, good. M and C. parameters. That is, m is one parameter. We call that as the gradient or the slope. And c is another parameter called the y-intercept.
Fine.
So we discussed in depth about that, right? How to calculate
Yes.
the m and c
Yes.
and all those stuff. So they are fixing. So we know that with respect to c, so this is our c value. So the c is actually when you substitute the x equal to 0, because that is where the y value of the line, when it meets that, so this point is 0 comma c, right?
Yes.
So this is the starting origin 0 comma 0. So when you substitute the 0 in the x value, then according to the straight line, the y value will be a particular value. We call that as the y-intercept, the c parameter. That will fix one parameter or one characteristic of the straight line. The second one is you take, for example, any 2 points, call that as a x1 comma y1 and x2 comma y2. Then we will say that we know that this point is our x1 and this point is our y1 and this point is our x2 and this point is our y2. This could be any 2 points on the straight line, because as long as it is a straight line, you keep the gap between the 2 points, very large value or small value or positive or negative, doesn't matter. So that is why it is a linear function, and so this will form a right angle triangle. And we know that the m is, so this is our delta x and this is our delta y. So delta x is x2 minus x1, delta y is y2 minus y1.
Fine.
So the gradient can be calculated with delta y by delta
Y
x.
by delta x.
Yeah, is actually y2 minus y1 divided by
x2 minus x.
Yeah, we derived this also, right? You remember that?
Yes. Yes. Yes, sir.
Because if the point is on the straight line x1 comma y1, then that will satisfy the equation like y1 must be equal to mx1 plus c. Another point is y2 actually equal to mx2 plus c.
x2.
So solving this simultaneous system of equation lead us to go to this gradient formula. M is actually y2 minus y1 by x2 minus x1. You see the mass, and also this is theta, right? So this is the same theta what it will make with the angle. So this theta can also be, if you write it as a trigonometric function tan theta, that will be opposite side by adjacent side.
Adjacent.
Yeah. So the delta y by delta x, then theta can be written as tan inverse of
delta y by delta.
Delta y by delta x. But delta y by delta x itself is our m. So we can write this also. So you see, solving system of equation is giving us one way of, if you know 2 coordinate points, then we can straight away use the algebra, the system of equation solution to get the gradient value. Or if you know the angle, the straight line made with the x-axis, then we know how to calculate the tan of that angle will give you straight away the m. So you see the mass, one way or the other, different topics and a different kind of problem we solve and make our understanding. They are all connected, related. When it is required, we need to come to that point, okay?
Yes.
So the second one is something like, okay, I write the first one in the case of y equal to, instead of mx plus c, I write it as a a1x plus a0. Okay, the full thing is you need to understand this as y power 1 is actually equal to a1 x raised to the power of 1 plus a0 x raised to the power of 0. Okay. Okay. So that is why it is a linear function, and it will look like a straight line in the graph, right? So the second one will be, the second family is the quadratic one. A will be equal to a2x squared plus a1x plus a naught. So this also we know that it is y power 1 is actually equal to a2 x squared plus a1 x power 1 plus a naught x power 0.
X power
It
0.
is actually a
Be a parabolic.
parabola, but it is called a quadratic function.
Okay.
Quadratic function or quadratic equation in x, that will be the definition for our y. It will look like a parabola. So like we discussed, this is actually our gradient and this is our y-intercept c, like how the m and c fixed that straight line and how they behave and everything. In the parabola, in the quadratic function, we need to understand how the a2 is working, a1 is working, a0 is working. That is our job to do that. Okay.
Yes.
And also we first learned how to solve a quadratic equation which is of the form ax squared plus bx plus c equal to 0. We solved it, I mean, different methods we have learned and everything, but instead of keeping it as a one value as a 0, we generalize that as let it be y in general. Then we are asking for if the y is taking a value, so this is actually y can be 0 or it could be minus 1 plus or minus 1. You see that plus or minus 2 plus or minus 3. Depending on that, we are talking about a parabola, a family of parabola. So it may look like this. Okay, so all these things actually we are learning separately, but we need to bring it together when we can apply and everything. So in this case, also we would be interested in this parameter, and most likely, let's say we have a parabola, and if this parabola in a straight line, we know that you can take any 2 points anywhere, but still the gradient can be easily calculated with delta y by delta x.
Right. Yeah.
The difference is how big is the gap between the x's and the y's, we don't care at all, because it is a straight line.
But over here it does.
Yeah, but if you go to the parabola, it matters. So if you take 2 points close to each other and 2 points too far away, the delta x and delta y ratio will not be the same. Okay, so that is where the interesting thing comes. Then we are considering the gradient is itself is going to vary with the point gap, the 2 points gap we are going to take. Then we have to think about, okay, how small I go in the gap between the 2 points, so that I will come to know what will be the variation. Can I get the same variation for the delta y from one point set to the other point set? Do you see that? Here, okay, I will put it 2 different points here. Let's say you take a point here and take a point here. So this will fit a triangle like this. But these 2 points, it will fit a triangle like this. You get that?
Yeah.
So this could be delta x1 and correspondingly delta y1. As we took very nearby 2 points, the variation of the delta x1 gave the variation of the y as this much. But if you have given a larger value, then this would have become like this. Okay, so now we are asking, here always the m is a constant in a straight line, right?
Yes.
But if you take the m will also be a some function of the x. You get that?
Yeah.
The parabola. So now we are questioning what is this function. So this function will be a straight line. So this m, the slope itself will vary as a straight line. It will look like actually if you defined the parabola like this, the slope, if you calculate correctly, it will look like a 2x plus a1. This is what the slope of a parabola will be. Okay. I will tell you how I got this 2a2x plus a1. But the whole point is, if you are taking a parabola like y is a2 x squared plus a1x plus a naught, this is nothing but actually we can write this as like a straight line, but the straight line itself, the m is a function of x. You see that?
Yes.
So this is actually, if you compare with this, we need to write this as actually our this mx. If you take this, if you take the x out, okay, if you take the x out, this will become a2x plus a1. So this itself will be a straight line. So if you consider this is m of x, so this will be a straight line. Okay.
Yes.
So meaning, if you have a parabola, let's say if you have a parabola, only half of the parabola like that, if you calculate, let's take, the uniform points on this, and if you have lot of points, and if you calculate the slope is changing, calculate the slope at a different point, and if you draw so this is our y to the x for the parabola. Now if you draw the m, which is actually our defined as the delta y by delta x. Okay, that will look like a straight line. Okay, so now we have the job to define this. So if you go one order up, then if you take a3x cubed plus a2x square plus a1x plus a naught, then the m of x, the gradient of this straight line, will be a parabola, because the function itself is cubic. Then the slope of if you take the point, every point to slope and try to plot it, so it may look like, okay, so the cubic function may look like this. And if you draw this is our y with respect to x, if you draw the m of m, which is actually delta y by delta x, this will look like a parabola.
Yes.
Okay. So with the knowledge of the gradient equation, we can always tell the function, or if you know the function, then we can tell how the gradient is, right? So we need to have a mathematical operation which can do both the job. So we call all those kind of calculation and computation as calculus. Okay. So the calculus is actually in the straight line, how much gap the delta x can be, no problem. Okay, no constraint. Okay. But if you go to the second case or third case or something, then if you change, then it is changing. The gap changes, the m value changes. So we are looking for, let's say, can I put a limit of that delta x going to a 0? If I look for, I know that whatever the function, like the y of the second point, that is x going from delta x, the minus y of delta x, y of x divided by within that delta x. You get that? So this will be our m.
Okay.
Which will be now defined it as a dy by dx actually. So simply we are asking, let's say if you draw a x to the y, let's say is some function, I go to I take 2 points. Let's say this is point number 1 and this is point number 2, for example. So this is our x1 comma y1 and this is x2 comma y2. We call this as a delta x, right?
Yes.
So actually this will be our so indirectly we can write this as a x comma y, and this could be x plus delta x, comma, that y will be y of x plus delta x, right?
Yes.
So we take this value, subtract with this value, so this is actually x comma y of x. So we take this value, subtract with, so that is what we are doing. So we are doing, this is our, that y of x plus delta x minus y of x. Okay, and this one will be our delta x. So we are taking the ratio of this to the this, that is why we write it as a y of x plus delta x. The second point y value minus the first point y value divided by the gap between the, so, and then we are asking that the gap to be tending to 0, not exactly equal to 0. We go to a smallest, so we are reducing this, so we are making this into a small gap. You see that?
Yes, yes.
But we go to a point where once we make it, okay, if I draw it like, if you have a line like that, so instead of having a full gap like this, I'm going to make it as small as possible. The requirement is, if I see the change from, so this will have a m1 value, this one will have a m2 value, so the delta x has to be, it has to be brought to as small as possible, as long as I know the variation from the delta x y1 to, if the variation from delta y1 to y2, delta y2, this, the same variation will be there for every gap. Do you get that?
Okay. Yes.
So that is what is happening. So if you take a triangle, so I go to a, let's say this is 1 and this is the, okay, sorry, y1, and I go to another triangle somewhere, as long as this could be xn and this yn.
Okay.
So if I know so I go to a smallest value of the change in the x happening, so that the y changes
it becomes
will be
a straight
everywhere throughout the function.
Okay.
That is what is called the limiting case of
Limiting. Okay.
the delta x going to 0
Tends to 0.
for the change happening with the y of x plus delta x minus y of x divided by delta x. This whole thing, this limit, we define it as we are differentiating the y with respect to x. Are you okay?
Yes.
Okay. So we know how to do that. For example, take it as a y equal to mx plus c. Right? So first, what is y of x? Yeah, we know that it is going to be mx plus c. Fine. What is y of x plus delta x? Is going to be m of, instead of x, where the x appear, we need to replace that with x plus, right? Plus c. So now we know both this. So we are going to use the, what is dy by dx? Nothing but the limiting case of the delta x going to 0. We are going to ask for this delta x. In the numerator, we are going to write y of x plus delta x minus y of x. It is going to be the limiting of delta x getting to 0 full delta x. So we substitute this one, that will be m x plus delta x m plus c. This whole thing is the first one, minus of our mx plus c, right?
Yes.
So this will be gone and this will be gone, right?
Yes. Even
yeah, the limiting case of delta x going to 0. In the numerator, we will have delta x m over delta x. So delta x, delta will exchange. So we don't. So the limiting will not be there. It will become the m itself.
Yes.
Okay with that?
Yeah.
Yeah. So if you do this for example, for our y equal to a2x squared plus a1 x power 1 plus a0 x power 0, then if you find dy by dx, which is actually defined as the limiting case of delta x going to 0, the same definition, y at a higher point, which is delta x away from the x minus the y value at the x itself divided by the change happening in the
Change
x,
in delta.
will come to 2a2 x plus a1. If you want, you can substitute and everything you can try. This will come to an answer like
Okay.
this. Okay.
Okay.
Okay. So give a try, like as we did. You can try, like y of x is nothing but our a2 x squared plus a1 x plus a0, and y of x plus delta x will be equal to a2 x plus delta x whole squared plus x1 x plus delta x plus a0. So you expand this and then substitute into this limiting case and simplify, you will get an answer like this. Okay.
Yes.
So but every time applying the limit and everything, it may get complicated, but with the understanding of what is going on, we will be coming directly. If the function is given something like that, if I know how the y dependent on the x, if the x is in the polynomial form, like the function is in the polynomial, it's a quadratic polynomial, right, in x.
Yes.
So can we differentiate straight away? So we will learn that and discuss about that next week. Are you okay with that?
Okay. Yes, sir.
Okay. Okay, then we will meet next week. Okay.
Thank you.
Okay. Bye now.
Bye.